Again, welcome to the first week of our Internet Programming and Internet Computing class. This class is a graduate and undergraduate class, as I mentioned earlier in the syllabus. And this lecture is basically you can access it anytime you wish. But it's supposed to be covering the first week of the classes, which is the week of August 23rd to the 30th. And the title of our first class is Introduction to the Internet and HTML Design. So essentially, as you notice, the topic of our class is Internet Programming and Internet Design. And basically, a good question at the beginning of the class will be, what is the Internet? One thing just not to think of as about Internet is that it is not one single entity or one huge massive technology that just started and happened overnight. It is, in contrary, it's a combination of mutually reinforcing technologies that happened in computer science, ranging from telecommunication, data processing, data storage, and databases. And all of these technologies put together over a very long, actually not a very long time, come to think of it, in about 40 or 50 years, started the massive technological advances that nowadays we call it the Internet. And as the technologies matured and got more and more advanced, the processes that were involved within the Internet and created the Internet also evolved. And in the next few lecture slides, I will go over the origin of the Internet and how it started from a basic project and grew up to become the massive entity that we know as a fusion of a number of technologies, and we call it the Internet. 40 years ago, there was a question within the research community and also essentially the telecommunication community, that could we change the way that voice and essentially data is passed over the telephone lines. And the idea started by researchers thinking about the possibility of sending packets of information on one single circuit, as opposed to networks that were basically switched circuits. And I'll talk about packet switching and circuit switching a little bit later, to give you an idea of what the question was and what the answer or the solution to the question became. And in the 1960s, again, the scientists in MIT were thinking about the possibility of packet switching, started also talking about a galactic network. That is a huge network of connected computers, and any computer connected to this system could access and share the information from any other computer connected to this galactic network. So back to the early ages of communication, the idea for that started the modern age of communication, or modern era in communication, was with the advent of telephone. And as more and more people had access to telephones, the solution was basically to find a way to connect a sender to the receiver of the call over a communication channel. And these communication channels were basically the communication circuits. They were called communication circuits. They were simple copper lines, and when you wanted to connect a person from location A who's calling a person from location B, both these locations would have their own switchboards, and an operator would physically connect the call from person A to the the physical location of person B throughout this switchboard. If you think of this, you easily see that there was a massive problem with this solution, or basically the circuit-based solution. And that is, if you had 3 switches on each of your switchboards, and person A wanted to call person B, they would occupy a physical dedicated line over the entire network, which was the telecommunication network, or the telephone network. And so the scientists started thinking about packet switching, and the idea is that, and so let me elaborate a little bit more on this circuit switching problem. Let's assume that we have 3 switches available, and we want to call from Victoria to Houston. If 3 people call from Victoria, let's say that one person calls from Victoria to Houston, another person from Victoria to Dallas, and another person from Victoria to San Francisco. Now, if a 4th person wants to call any location, they would have to wait because all the 3 dedicated lines are being taken. And the solution is packet switching. And so the scientists started thinking about, oh, let's see, how about instead of these people taking the whole line, how about we take each individual's data, or the voice representation for that regard. We put all of these information that are coming out of Victoria, put them in a packet, in a box, essentially. And then we send this box over one single line. And then when it goes out, it will have within itself the information where it is going. So when it's going out of Victoria, it goes to the switchboard, and the switchboard then distributes these packets throughout the network. And that was the birth of packet switching. So again, the idea was to packet all this conversation in a box and send them over a single line. Now, you can easily see that there are several advantages. First of all is the efficiency of your communication. So given you have a fast packaging mechanism, even the users will notice what's happening to their data. And of course, you're using one single line that saves a lot of money and a lot of maintenance to go about. You will have faster communications because people won't have to wait for the lines to be free, and it will be cheaper because again, the dedication of one single line to multiple users throughout the packet switching technology. Now, if you wanted to visualize how the circuit switched communication worked versus the packet switch communication. So in the top figure up here, captioned packet switcher, you have switches from one location to the next. And when a person A wants to call a person B in the destination, the switchboards essentially dedicate these lines in such a way that the entire physical circuit will be connected. And when this connection is made, then from the leftmost switch, the top connection is taken from the input switchboard, and the bottom connection from the output switchboard. And the bottom connection in the middle switchboard, in the input of the middle switch is taken, and the middle switchboard in the outgoing, and so on and so forth. And as you can see, these switches cannot be, or these connections cannot be used or shared by any other user. And once 3 users connect to 3 other users in the destination, which is to the right side of this switches, nobody else could basically be able to make any other connection. Thinking of this technology, or the switchboard technology, you could still possibly connect from one computer or from one network to another network. And then you still will be able to connect from one network to multiple networks. But you would have to have multiple computers. Basically, one computer per connection per network, or per connecting network. That's the requirements that you had in circuit switched networks. Or conceptually thinking about it, it would be like you could still make multiple phone calls, but you would have to have, for any of your contacts, you would have to have one dedicated cell phone. So you could, if you had like 10 people on your contact list, you would have to have 10 networks to or 10 cell phones to be able to make all these calls. The packet switch networks, on the other hand, would have switchboards which basically take this information from multiple users and put all these informations into packets and then send all these packets via the internet or one single dedicated line. And then it would be the router's job to route each of these packets of information from one location to the other, or from one network to the other. Now let's talk about what happened, how the internet began. In the year 1964, the DoD's Advanced Research Project Agency network started connecting computers by hooking them up on phone lines. And the idea was to create the first network of computers from 4 universities, essentially 4 nodes, in such a way that they could share data and information. And these 4 nodes, which were connected by 4 leased phone lines from a telephone company, were the University of California at Los Angeles, UC Santa Barbara, Stanford Research Institute, and University of Utah. And to make these connections work, or basically to make any of the networks to be able to connect and access the information and data from the other 3, interface message processors, or IMPs, were used. They were basically the first routers in the world. What would happen, each of these interface message processors would get information from within the network they were basically located at, parse the destination for these packets, and then route them to the next available router, who would basically be able to parse to send them to the next router and basically pass this information over the landlines. 5 years later, which was 1969, after the first funding for this network started, the first landing on the moon occurred, and that overshadowed another, basically I would say, similarly important advance in the human technology, and that was the creation of ARPANET. Actually, ARPANET, within 5 years of its funding, it started connecting all those 4 networks. So what did this interface message processors do? Interface message processors were acting basically like a universal language translator that we have right now these days, but for machines. What that means is that each of those 4 networks, they had different computers with different operating systems and basically different codes and languages. And these interfaces or interface processors would make a universal and seamless connection between these different networks with different properties. The protocol that they were using in order to transfer data or to route data from one node to another node was called Network Control Protocol, or NCP. And that Network Control Protocol was in effect and in work until 1983, where TCP/IP protocol was created, and it actually replaced the NCP protocol. In the early 70s, ARPANET started growing, but the growth were incremental, and so little by little, more and more networks were basically connecting to the ARPANET, and more sophisticated interface message protocols or internet basically routers, processors were created. The network grew to about 30 institutions in about 1973, and that year was the year that email was developed in order to make the message passing from one institution to the other institutions basically integrated within the network itself. And as the years went by, more and more application protocols started basically developing with the development of file transfer protocol, which was enabling two remote computers to share files within the network. Telnet, Simple Mail Transfer Protocol, or SMTP, and so on and so forth. However, by growing this network, the problems started beginning, and the major problem was the explosive growth of this single network that was just becoming more and more sophisticated. But however, by the bandwidth that was available in the days, the massive number of connections were becoming a problem for the overgrowing network of ARPANET. This led to the invention of Ethernet, and if you think of Ethernet as a connection of computers, you can call it a local area network, basically. That is that you have a bunch of computers within a local area, such as a building, a department, and so on, and you hook these computers over a shared line and basically connect them together, and then connect this network with an external router to the outside world, and this becomes your Ethernet. There are three different types of Ethernet or local area network connections that you can have, and here are in this picture you can see these different networks. You would have in the star network, you'd have a hub or switch, which basically all of your computers are connected to, and then that hub is connected to the outside world. You can have a ring network in which your computers are connected on a sort of a ring connection, and that would enable the passing of the data even if one of these computers or one of the routers or routing mechanisms within the ring are out, and you may have a bus local area network. And of course, if the bus is broken, then computers that are past the broken line will be taken out of the network. But the Ethernet and essentially the ARPANET didn't stop, and the technologies started advancing and becoming more and more sophisticated. And in the 70s, National Science Foundation initiated founding to build a network that would connect a university system, and it was called CSNet. NASA later on got involved. PC was introduced by IBM, and in the 80s, 1983, TCP/IP replaced the Network Communication Protocol, or NCP. And because the TCP/IP protocol was representing the very inexpensive network representation through 7 layers, from physical to application layer, it became more and more popular, and suddenly was adapted by or adopted by many network designers. And as more and more computers and networks started popping up and connecting to the web of these networks, the domain name system was developed in order to create a standardized naming for several connections on the network. In 85 or 84, the Congress gave National Science Foundation a budget to create the first ever national network that would connect all universities to this massive backbone. It was called NSFNet Backbone Network. As you can see, it included a handful of universities, and then in 85, 1 year later, they turned out to be 30, and in 88, the number of connecting networks grew up to about 5,000, with a number of supercomputing centers that were set up within the nation. And finally, in the 90s, the internet backbone changed, and that was when it was basically started becoming the internet. And the internet backbone changed. Some of the supercomputing centers stayed the same, but essentially some of them moved around. And this is the luck of the internet in the early 90s in the United States. And of course, many other nations, up to 50 by that time, were connected and hooked to the internet, or were a part of the internet network. So in early 90s, like 90 or 91, Tim Berners-Lee created what is called World Wide Web, and it was created in European Laboratory of Particle Physics, or CERN, in Geneva, Switzerland. And its reason to create this World Wide Web was to make cross-reference documents easier from one computer to another. And the idea that Berners-Lee had, who is basically the father of HTML, or hypertext markup language, was to use a method called hypertext linking, so that you would be able to access an information by linking from one document, by linking it within another document. So if you remember the latest controversy with CERN, they are pioneers of creating things that are basically never thought of before, and they become the leading technologies in the world. So what hypertext linking is, as I said, is you can access a web page or a document from your currently open document. You can access another document by just clicking on the link that references that remote address for that external document you're interested in. It could be also a cross-reference within your own document, or within your own network as well, or within your own web page as well. Okay, now let me start by talking about, or basically giving giving you some web or W3 terminologies, and defining some common terms here that we will be using throughout this course. Most of you are already familiar with most of these terminologies, but just to go quickly over this. A document on a web is called a web page, and it is identified by a unique address called the Uniform Resource Locator, or a URL. A URL is also commonly referred to as a web address, and so we use these terms interchangeably. What a URL is a form of a URI that is a Uniform Resource Identifier, and it is a generic term for many types of names and addresses on the web. So URL is a page locator. URI is the identifier for many other different resources on the internet. A website is the location on the internet where your web page and the related files are. So my website basically is can be accessed by the URL to my website essentially, and if I type the URL, as you can see here in the address bar, you can access my website, and the website contains several web pages that contain the web documents I created and the resources such as my publications, images, and videos and data about my work and my research. To display the website, we need to have a program that is called a web browser. And web browsers look at download or actually take the information that is within the web page's HTML files and parse them and then show the data in a visual a visual browser or a visual page. Now, when you want to look at a web page, you will type the URL of the page in your browser. Your browser send a request to the web server where that page is hosted, and the web server retrieves the HTML files. And as we see later on in this semester, if we have active server pages or ASP programs, it would retrieve the information, it would perform the processing that is needed. In case of HTML, it does not require that, and then creates an HTML document in which it sends back to the requesting client or requesting web browser, and the web browser shows the web page on the screen. However, again, if you're just requesting HTML web pages, the HTML file is being retrieved by the web server and is being delivered to your web browser. And the resulting HTML, or essentially the retrieved HTML that the web server sends back to the browser, is called a response. There are a number of different browsers that you can choose from to show your internet pages or web pages, and the Microsoft Internet Explorer at the time is the most popular web browser on the market. However, it was not the first browser that was created. The first browser was named Mosaic, and it was created by NCSA in 1993, and in 1994 Netscape created the Navigator, which was basically at the time the most popular web browser, and it had the share of about 70% of the market at 1994. Netscape maintained its control for the browser market until 1996, when the Microsoft started entering the market, and then the so-called browser wars started, and the two giants, Microsoft and Netscape, fought over controlling the browser market. The war began over the DHTML, which was a combination of various technologies, including HTML and JavaScript, to allow web pages to change their appearances after they were loaded. For example, an example of the DHTML would be to include the ability to position text and elements, change documents, background colors, create effects such as animation, blinking text, and things like that. Both earlier versions of both Internet Explorer and Netscape Navigator included HTML elements, but they were incompatible. And so when the web developers were including the HTML elements, they would have to create web pages for both browsers in order to make sure that their web pages will be seen accordingly, actually properly, by different users. So the problem of this incompatibility persisted, and the two browsers were not giving up until the World Wide Web Consortium, or W3C, was established in 1994 at MIT to oversee the development of web technology standards. And when they were drafting their DHTML recommendations, they basically looked at both properties of the HTML elements in Internet Explorer 4 and Netscape Navigator 4. And as a result, what happened is that the W3C adopted as the formal standards for the DHTML the Internet Explorer, or IE4 DHTML standards, or DHTML elements. And this essentially resulted in a massive transfer of the users from Netscape Navigator to Microsoft Internet Explorer, and the decline of the Navigator, and it actually stopped the production of newer versions of the Navigator later on. Out of this, the browser wars, some good happened, and the greater benefit of the browser wars was that it forced the web industry and the community to rapidly develop and adapt advanced web page standards, including the JavaScript, CSS or cascading, style sheets, and the HTML. And this adaptation or adoption happened in such a way that it was cross-platform, and it was basically consistent over various browser types. By 2004, IE, or Internet Explorer, was basically winning the market and was creating a monopoly over the browser market. Up to 95% of the browsers users used Internet Explorer. But there was a newcomer called Mozilla Firefox, which was a new open source browser or open source software. And because of its open source properties, it started becoming popular over for several developers, and started gaining momentum until it reached at about 44% of the users of browsers in the market are now using the Firefox, compared to 46% that are who are using currently the Internet Explorer. The good news about being open source with the Firefox was that it was open source, and many developers started modifying this, and it became more and more popular and easier to use, and basically more and more compatible with the latest web technologies and programs. So how, as I mentioned earlier, the World Wide Web was created as a markup, and basically the web pages were designed as markup languages. And the markup language that Berners-Lee had in mind and started was basically a hypertext markup language, and people started creating web pages using this HTML. Um, and this markup language allowed the browsers to be able to allowed the creators or the web developers to write their web pages in a formatted way, and then the browsers were able to look at these formats that are written or basically programmed within the web pages, and then parse these pages and visually create the resulting documentations that are programmed within the HTML codes or the HTML files. A markup language essentially is a set of characters or symbols that define the logical structure of a document and how it should be presented or it should be displayed. I don't know how many of you are familiar with a markup language for text editing. It's called LaTeX, LaTeX, and it's one of the mostly basically preferred languages to write scientific articles and books in the public for publication. What it is it's composed of several tags, and when you type your text within these tags, it would when it's processed and interpreted by its processor or its language interpreter, it would represent the actual text that will be displayed or printed when you are publishing your book. The HTML language was based on an older markup language called Standard Generalized Markup Language, or SGML, and this language defines the data in a document independent manner. So it would not matter what kind of document or page you have, the data will be represented regardless of the type of your documents. That has been achieved by separation of data in a document from the way that it is being formatted. So and each of the elements in an HTML document is marked according to its type. So you would have paragraphs that are marked according to their types. You would have headings. You would have different table and different types of attributes and elements, which you could generate your data and put them according to the way that you want them to look. Like SGML, the HTML documents were also essentially text documents, and the formatting instructions were contained within markups that are called tags. And I will talk about HTML syntax and HTML tags in a few moments. But essentially, for those of you who are familiar with HTML programming and HTML documents, it's basically a way to represent whatever you want to show and to hard-code it or to program it within various tags, and then your HTML parser or your web browser would read this file, take each of the tags and the data within the tags, and then represent and display the data accordingly. As I said, HTML documents are text documents, and they contain formatting instructions. And these formatting instructions, as I said, are called tags. These tags determine how your data is displayed on the web page. You would have a range of formatting documents or formatting tags or HTML tags that would allow you essentially to use formatting commands to make the appearance of your text the way that you want to be controlled. There are other HTML tags that allow you to display, for example, graphic images or other types of objects, such as multimedia or music. You may have tags that would allow you to link, which was essentially the hypertext property of the HTML, would allow you to link various documents either internal to your website or external by using URLs within your documents. The HTML tags are basically enclosed in brackets, and usually most tags have beginning and ending tags, and you can have, for example, the beginning of a paragraph and then the end of the paragraph. The difference between the closing tags and the ending tags is that a closing tag starts with a forward slash, and that determines that this is a closing tag. So, for example, if I want to type a word in boldface, in the HTML code, I put the letter B in brackets, and then I put the word, and then after the word, I put the letter B followed by a forward slash in or actually a forward slash followed by letter B in a closing tag, and that would indicate to the browser that this text or this word has to be bold-faced, and it will be shown bold-faced in the browser. A pair of tags in the example that I gave you earlier, like the letter B in the opening and closing tags, it usually is referred to as an element, and the information that are contained within the element's opening and closing tag is basically referred to as its content. Some of elements do not require a closing tag, and you can just simply put the opening tag and type your your content, and that would essentially, or sometimes they may not even have a content, and that would indicate your empty element. One of these types of empty elements is basically a horizontal line, which whose tag is basically the letter H and R in the enclosed in brackets, and you cannot represent any information within these empty elements, and they essentially create the specific type of formatting that they do to your HTML document. This list shows a few of the basic HTML tags, and as you see, each of these elements is described by either the formatting that they do, or the essentially extra information that they include within your HTML document. So the tag B is for typing boldface. You type your text or your content between the opening and closing tags. The body tag encloses the body of your HTML document. We talk about it a little later. BR is a tag for a line break. Center is a formatting tag that would center the content or everything that is after the center tag and before a closing center tag. The element head includes the heading of your page, also containing the title, and I talk about it a little later. You could have the heading elements H1, H2, H3, all the way to H6, and they would represent the heading of your documents. You could have and H1 is the outermost heading. If you think of like a chapter, the H1 is the heading of the chapter, and then H2 is the sections, H3 is the subsections, H4 are subsections, and so forth. HR, again, as a horizontal rule, or it basically puts a horizontal line in your document. The HTML tag is a unique tag. It's basically encloses all or the entire HTML document that you have, and any HTML document would have to have this HTML tag. I is for italic. IMG is a tag that inputs or puts inserts an image file in your document. The tag P identifies a paragraph, and the tag U identifies the tags that are to be or the content that is to be underlined. This web link is the link to the W3 website containing information about all the elements. So this web link is the link to the documentation about all the elements, and there are quite a lot of these elements in the W3 website. Now, let's see if we can get to it. And here it is. So you type www.w3.org/tr/html/index/elements.html, and this is index of all the elements that exist, and you can click on any of them and it would take you to the definition of the tag, how you should use it, whether or not it is deprecated in later versions of HTML. All of the HTML documents, as I said in a previous slide, must use the tag HTML, or essentially the HTML element. This is called the root element, and the root element contains all of the other elements in the document. This element will tell your web browser to assemble any instructions between this root element tags into a web page. Again, the opening and closing tags are HTML and /HTML respectively. Two other important HTML elements that we have are the head element and the body element. The head element contains information that is used by the web browser, and you can place this head element before the body element right after your HTML tag, and it has to contain the title element. And the title element is the text that appears on your web browser title box when you load the web page into your web browser. All of the other elements that you contain in your head element or in the head element do not affect the display of the HTML document. Only the title element affects the the title of your web on the web browser. And this head element and all of the elements that you put within its closing and opening and closing tags are called the document head. So the document head is the head element and all its contents. The body element is essentially everything that's contained within the body opening and body closing tag. And you could write your HTML codes and tags within the body, and they would appear on the web page. And this is called the body document. When you open an HTML document in a web browser, the document is basically put together according to the instructions that its elements have. And the process that the web browser takes to assemble and format your HTML documents is called parsing, or rendering of your HTML file. Okay, so if I want to have, for example, a simple boldface line in an HTML web page, I could just open a text editor and I save it as an HTML file and name it code 1. Then I create the body, the HTML tag, the head tag, and my head tag contains the title, and that would be my first web page. I need to close the title tag. I need to close the head tag, and then in the body of my HTML document I put the paragraph, and then within that paragraph I make a boldface element, and within the boldface element I basically type my first line, and I close my HTML document by a closing HTML tag, and I need to save it. And then when I go back to my file, as you can see, the first line is being boldface, and the title of my page is called my first web page. That was the title that I created. Now if I take this element out and I refresh the file, it will not be presented in boldface. As you saw, the HTML is not a case-sensitive markup language. So if I use the capital B instead of the lowercase b, it would not make any difference as far as the rendering of my text would look like. And just to test it, I would like to show you how it shows. So if I refresh the text, it will become boldface again. There are newer generation or next generations of HTML. This is a language called XHTML or Extensible Hypertext Markup Language, and that XHTML is case sensitive, and you must use lowercase letters for all the elements. For this reason, we need to make sure that we use lowercase letters for all of the elements that we use in our HTML, so that if we need to import them or use them in an XHTML document, we could our files would still work. There are various parameters that we could use to configure the HTML elements, and these parameters are called attributes. We place these attributes before the closing bracket of the opening tag, and we must separate this attribute from the tag name or all other attributes that are in the opening tag. For example, if I want to import an image into my file that I have here, I can use the element img, and this element img would require a source, my picture.jpg, and then I could have an alternative text if the picture is not available. And so this would this attributes image has, as I said here, I gave it two attributes: one image file name to attribute source, and one text or a string to its attribute alternative. And if I refresh my text, it would require to put the picture here. It looks at the folder where my document is located, which is this codes folder of the first lecture. There is no image here, and therefore it does not show the image, and it shows the alternative text that says that picture not available, and that was the text that I put in the alternative. So essentially these are the attributes of the elements. The attributes of the elements are also within that w3.org website. The link is as www.w3.org/tr/html401/index/attributes.html, and you can see all of these attributes, the type of attributes they are, and where they are used. So there's a long list of these attributes, and again you can click on them, and they will the links would take you to the place where the description of these attributes is represented. One thing to make sure that you will do is that you will have to put these attributes within the opening document and before the closing bracket of the opening document. And when a web browser parses or essentially renders an HTML document, it ignores non-printing characters such as all the tabs and line breaks that you will have. And the final document that appears in the web browser only includes recognized HTML elements and the text. You cannot use line breaks in the body of an HTML document or insert any spaces before and after any paragraph, and the web browser and expect that your web browser would show them to you. The web browser only recognizes the BR attribute or the P element, BR element, which is the line break, or the P element, which is the paragraph element, and it has to be in an opening and a closing tag in order to contain the same paragraph. Most of the web browsers also ignore multiple and contiguous spaces on a web page and replace them with one single space. And just to show you a simple web page and that how it looks like, let's just go back to our file. Okay, here we are. Just before I do that, I'll show you that I just copied and brought an image, and I call it sun, and now it's within the same folder, and I don't have to worry about the referencing of or the location of the file. So I'll go ahead and I'll put in the title of my page. I leave it at my first page, and then I have the body of the page. So let's make the first heading for my page, and this heading I will call it the sun page. Now if I run the page, it would tell me that the sun page, and it makes everything the heading of the attribute. And as you see, I didn't put the closing tag. The closing tag I put didn't have the /. So now the first heading of the page, as you can see here, contained within the H1 element is the sun page, and that is how the heading looks like. And then I have a paragraph, and within the paragraph I have my first line, which is shown in the boldface here, and then I have the image that is placed right after the first line. And if you notice, I have in my text editor, I have a line break between the image and the first line, which is also in bold. Let me just take this boldface, and so I have the bold attribute, the bold element. The content is the first line, as you can see here, but there's a line break here. However, the web browser ignored that line break. If I want to contain the line break, I would have to put in a line break element, and then the first line is appearing on the first line of the paragraph, and the line break at the end of the first line breaks in the browser and goes to the next line, and in the next line the image wants to appear. So let us put a second heading and add the second heading to our file here. So right after H1, I create a heading H2, and I call it the second sun heading, and I close the attributes. So as you see, I can have them either within multiple lines of this the element, or put everything on the same line for small elements. It has to be H2, and now let's run the page, and as you can see, the second heading appears smaller than the first heading. Next is to essentially type the image in, and I need to put this image, the sun, and then I could add a title to it. Let's make a boldface, and let's call it star. Let's see how it looks like now. As you can see, it shows star right after the image, and you could put if I want the sun to appear at the end in a new line after the image, or the text to appear at a new line after the image, I need to put a BR tag at the end of the image. And that is what I did. Now I could, and again I'm using tab to just indent my text in my my HTML document, but these tabs and extra spaces are ignored. I can have multiple lines and so forth. So this is basically the first HTML file that we write, and that essentially shows how you could create several objects and several web pages. One last thing quickly just to remind you is the P element, or the paragraph element. Notice that I put everything in one single paragraph, and so the lines are basically, they're kind of very crowded, as you can see here. In order to make it a little more structured, I can have my first line that I have it on top here. I can have it put on its own paragraph, and then I can put my other lines on their own paragraphs. And so I created one paragraph which contains my first line, and then I put the image in there, and then I contain my second and my third lines on to another paragraph. And here's how it looks like. So it makes the separation between each paragraph and the objects and the paragraphs from each other. So now to create a web page, we could either use text editors or we could use HTML editors. What I showed you previously is that because HTML documents are text files, I just opened my notepad, I typed all my HTML file, its elements, tags, and everything within the text file. I saved it as .html or .htm, and then when I double click on the file, it automatically renders into my Mozilla Firefox web browser, because that is my browser, my default browser. And when I'm looking at my my HTML document, I can't really in the notepad, if I'm not trained, I can't really see how it looks like, and it becomes more and more complicated to kind of think about your HTML document by looking at the text when your HTML document becomes more and more complex and complicated. For that reason, there are HTML editors such as Microsoft Front Page or Microsoft Dreamweaver, and these applications allow you to use your HTML programming in several ways. You can go to the code section of your web editor or HTML editor and hard code your HTML code as if you were doing that in the Notepad or other text editors. Or you could essentially use their design view and graphically design or visually design your HTML document, and they would automatically create the HTML code and markups and tags for you. One advantage that HTML editors do have even for those people who want to hard code their HTML codes because of the efficiency or the optimum coding and reasons like that, is that these editors would highlight your tags and your elements accordingly, and you will have ways to, before you deploy your web page, you will have ways to check for errors, or to check, see if you forgot to close a tag, and so on and so forth. And you could use any of those editors, or you could use any text editor of your choice for developing the HTML web pages in